So good evening all once again. So as you can see in poster, we are going to see fluid mechanics, specifically chapter 0, which means that we are going to see the overview. We are going to connect the fluid mechanics, how it goes, what is fluid mechanics, idea of fluid mechanics means the most important before learning any subject is understanding why we are going to learn it. So that's what I'm going to discuss today. And every subject is designed so that you can learn something from it. So there is nothing that there is something very hard in it. Everything is easy. Just we need to connect the dots, what it wants to convey. So same way, here we are going to learn fluid mechanics in a playful manner and considering the real life instances and examples, and we will connect the dots. You all people will really connect with your real life. So while starting fluid mechanics, we'll start with 3 questions. What is fluid? Why is that subject? And how we are going to learn it. So fluid, what is fluid? It is a substance which is having a less cohesive forces in the molecules in between them. In solid, there is a compact arrangement of molecules. They don't move in their position. They just vibrate on their own position. While in why this is there in solid? Because there is a strong cohesive forces in between 2 molecules. Whereas in fluid, the same thing, molecules are there, but there is cohesive force is quite less in strength. So that's why there is no regular arrangement in fluid. And considering this property of molecules, the definition means the definition of fluid in view of fluid mechanics, we make that deforms continuously under the influence of shear stress. Means if you apply a shear stress on solid, like if you draw wire from a steel, then you apply stress and then small amount of strain is observed. Strain means deformation. Okay. Whereas in case of fluid, the deformation is not controlled. If you apply stress, then you cannot control the strain. Means कितना flow हो जाएगा आप बता नहीं सकेंगे, है ना? So that is the difference in solid and fluid in the view of fluid mechanics. So in solid, if you know, stress is directly proportional to strain. So the same thing in fluid, stress is directly proportional to strain rate. Means deformation rate. Means fluid deforms irregularly after applying a small stress only. Whereas in solid, the cohesive force keeps bind, molecules kept bind due to the strong cohesive force. So that is the basic difference between solid and fluid. And as you all know, the fluid flows and that all definitions are correct, that all meanings are correct. Only you need to understand that there is a difference of force in molecules. Okay. So then comes second question. So why we are going to learn this fluid mechanics? So this is an wholesome question. It covers the basic, means all the ideas why we are going to learn this means difficult subject, fluid mechanics. So it comes to the applications only. As you know, rain comes, the seasons change. So all these phenomena, all the natural phenomena are governed by fluid mechanics. And using those natural phenomena, understanding the law behind that, we have developed the applications of fluid mechanics. The basic idea what I'm going to say is all the things governed by the fluid mechanics while designing a car, designing a industry, designing many industrial processes, reactors, all are governed by fluid mechanics. So that's why it is important to learn fluid mechanics. As many of you would be from this food technology, dairy technology. So what you are going to see there, if you are mixing and milk, so that is going to be in reactor or some vessel. So there also you need to stir that vessel properly.
Yes, sir.
Yeah. So
Yes.
there also fluid mechanics is solely fluid mechanics involved in that. So similarly, so the first vehicle, the most widely used concept of fluid mechanics is in vehicles, aircrafts, and ships. So we are going to see in detail how it is being means employed. So now power plant. How many of you know that heat exchanger term?
Yes, sir. Yes, sir.
Yeah. So that heat exchanger, that the basic idea behind that, the governing body in heat exchanger is fluid mechanics. How fluid flows in the pipes and all that governs the heat exchange between bodies. So in human body, the blood flow, the blood vessels, our heart, that doesn't means that is extremely beautiful example of fluid mechanics, human body. Then all we know the piping and the piping system in our house, in industries, everywhere there is pipe involved. So there exists the fluid mechanics. So the basic idea what I want to say is everywhere there is fluid mechanics. So that's why we need to learn fluid, and fluid mechanics makes the basics of all the subjects. You may having heat transfer, you may be having mass transfer, you may be having reactor engineering. So all the subjects you will understand once you understand the fluid mechanics. So that's why we are going to learn this subject, fluid mechanics. So this image, if you can see, this is in contact in pattern between the different fluids. So all these things we need to understand before going for the application. So that's why this fluid mechanics subject is there. So after this why question, the most important thing what we are going to learn in fluid mechanics is answered by how. So in complete book of fluid mechanics and complete syllabus, we are going to discuss how we are going to apply this fluid mechanics. So that's why we fluid mechanics, that branch is differentiated in dynamics and statics. So in statics, how many of you have traveled on boat? Many of you are from Kolkata, na?
Yes.
Okay, so you understand better than me how boat goes. So that concept involves buoyancy. You know buoyancy?
Yes, sir.
Okay, so that buoyancy thing is governed by statics part, and also the pressure of liquid column. These all things are governed by statics part. And dynamics involve fluid in motion. You all people understand the basic difference between dynamics and statics, so I won't go in detail. Now dynamics is further divided into hydrodynamics and gas dynamics. So hydrodynamics means it involves liquid, more of liquid, and gas dynamics it involves gases. So what is the example of hydrodynamics? Hydrodynamics, which is further, hydrodynamics include liquid, and if liquid is water, then we call it hydraulics. Understand? So in gases also, gas dynamics involve all the gases, but if gas is air, aerodynamics. So what these things means, what are the applications? We have to connect the dots. Means हमें connect करना है कि हम जो life में, real life में what we are seeing examples, how come that fit into these branches. So अभी in recent times that bulldozer is on fire, huh? How many of you know JCB bulldozer?
Yes, sir.
Okay, so that hot topic all of you know, na? So that JCB involves the major part of this hydrodynamics and hydraulics. The most common application of that is JCB, that lifting purpose and all. So what happens is fluid have some energy. Because of mass, it contains some energy. So that energy is employed in lifting materials and lifting cranes and all. So that thing we are going to learn in details in our classes. So what I'm going to tell you in this first session is what we are going to learn in our whole complete syllabus. So the most important thing is we will go like we go understanding applications like this JCB. So you will remember every time that hydrodynamics, hydraulics is used in JCB. So this approach will follow. We'll go in detail in our coming sessions. Now I will just overview you about the subject. So in aerodynamics, like in aeroplane, how many of you traveled to aeroplane? So you may have seen that while takeoff, that flaps of aeroplane that remains like slightly downward. Why is that so? To cut the airstream. That is also correct. But the most important thing while takeoff is creating an air pressure on means creating a thrust so that something can be held by the air. मतलब एयर किसी चीज को अपने ऊपर रख सके ऐसा अपने को प्रेशर क्रिएट करना है. फॉर क्रिएटिंग सम थ्रस्ट दिस फ्लैप गोज डाउन सो इट क्रिएट्स एन स्पेस व्हिच होल्ड्स द एयर व्हिच क्रिएट्स थ्रस्ट. So understanding this way, you will learn. Now there are many topics in fluid mechanics. Means a complete fluid mechanics consists of kinetics, dynamics, some boundary layer, internal flow, external flow, and the flow visualization, Reynolds transport theorem. All this topic you may have listened somewhere in your curriculum. So we in fluid mechanics we go through example. हम इनको ऐसे समझेंगे कि हम पहले एग्जाम्पल समझेंगे उसके बाद टॉपिक अपने आप उसमें लेकर आएंगे, है ना. तो हम पहले ऐसा समझेंगे. अब यहाँ हियर वी आर क्रिएटिंग थ्रस्ट. सो इन क्रिएटिंग थ्रस्ट what is involved? First is the flow behavior, how the flow is. Then it is external, internal. So all these things we connect. So अब तक हमने क्या क्या देखा कि what is fluid, why we are going to learn the fluid mechanics, and how we are going to learn. So how we are going to learn, we will consider the examples first, then we will go and connect the topics, the concepts. Okay, so going ahead. So approach to answer how means ये जो how topic I wrote here, how we are going to answer that how. So first I told you we'll go through application. So the second thing involved is kind of fluid involved, है ना. The fluid involved in aeroplane. What is the fluid we are dealing with while considering aeroplane? It is air. Yeah. Air. While considering pipeline, what can be the fluid? It may be oil, it may be water, it may be some chemicals. So all the fluids having different behavior. All the fluids will be having different behavior. So that's why we are going to understand first what is the fluid involved. The basic idea, the first point we should consider is what is application, then what is the fluid involved in that application, then comes the type of flow. So anyone would like to answer how many types of flows are there? Laminar, turbulent, and streamline flow. So I would like to tell you that there are number of ways to classify the fluid flows. The first comes viscous, inviscid, internal flow, external flow, laminar flow, turbulent flow, compressible, incompressible, natural flow and forced flow, steady flow, unsteady flow. So all this we are going to understand in detail in coming lectures. So currently I will focus just on internal and external, because while considering the example, the most important aspect we should see is the flow is internal or external involved in this application. So I will give you two examples for internal and external. You will understand properly. Suppose one car is going on the road. So while going on the road, air is flowing over a car. Means actually car is moving, but air is flowing over the car because we are cutting the air. So that kind of flow is air is flowing over car. What kind of flow is that? What do you feel? Means it is internal or external?
External.
Okay, very good. So that is external flow. Whereas if water is flowing inside a pipe, that is internal flow. So this is basic idea. the first we will consider is it is internal or external. Then comes the most important point, over which the 2-3 chapters are based in fluid mechanics syllabus, that is flow visualization. It includes this next 5th point also. So flow visualization means, if you consider a car, then you understand that that is an external flow, air is flowing above a car. But do you know how air is flowing? It is going this way, it is going this way, this way. Here it
So
is
the
going
second
inside.
one.
It is going inside window. What? Sorry.
So the second one that you said. The
Second
way.
one.
Like
That.
above the car, like from front to
Okay.
above.
Yeah. So what I'm going to say is, fluid may flow anytime. Means it may go from below the car, between means this tires also. It may enter in your window also. It may go above. It will make means apply pressure on this window, this mirror, this glass, front glass. So we need to visualize how the flow is flowing over this car. This is just one example of car. Now consider, I will give you example of your milk only. Uh, if you are mixing a milk and you have added, let's say, lemon juice in it, or any taste, or means any flavor or color. So if I add here, if I add the chunks of color or chunks of that material what I'm going added, it is here only. If I will not mix, then it will remain here only, है ना? But if I put a stirrer, it will completely get mixed. But how come you will come to know that that is completely mixed or not? कोई बता सकता है कि मैं कैसे पता करूंगा जो मैंने ऐड किया वो completely every part of the vessel में मिक्स हो चुका है? So we will see, हम किसी एक पार्ट का सैंपल उठाएंगे, या तो फिर उसमें फ्लो का टाइप कैसा है, फ्लो कैसा हो रहा है स्टिरर की वजह से, how the milk is revolving around this stirrer. So we will analyze this. So that is only the application of fluid mechanics. This is the basic idea behind studying the fluid mechanics. So flow visualization is must. Flow visualization से मैं I will go in detail. Suppose this is an river. Okay, this is an river, and suppose I put here ink डाल दिया मैंने यहाँ पर, है ना? तो ये ink is how will go with this flow. Yeah, so some ink will go straight, some will go wavy, some will spread here, some will go far, and some will be stay here only. So it is important to know how the particle of ink is going with water, है ना? What we are going to analyze is how this particle of ink is going with water. So that is only what I'm saying is visualization. Why it is important? Because in many applications we will have to understand that how this material, means what we have added in the fluid or some system or some reactor, some vessel, how that is mixed properly or not, and completely what we are adding is useful, means getting utilized or not. So that's why it is important to understand the behavior of this flow. The visualization means every particle of ink we are visualizing where it is, how it is going. So that comes under flow visualization. And then the method of visualizing flow are two methods: Eilerian method and Lagrangian. Some of you have know these terms, Lagrangian and Eulerian method. So now comes the example of that river. So here it is river. Suppose I throw an tennis or plastic ball here. So this plastic ball is flowing with the river. Okay, प्लास्टिक बॉल पानी में गिर गया, ये रिवर के साथ चले गया, बहुत बड़ा नुकसान हो गया 10 रुपए का, ठीक है. सो आई एम सीइंग इट, वो उसको बहते हुए मैं देख रहा हूं पर कूद नहीं सकता ना पानी में. सो दिस अप्रोच, व्हाट आई एम सीइंग इज बॉल ओनली, बॉल फ्लोइंग विथ रिवर. ओके, so this ball is now currently here. Now it will go here. I will cry seeing that ball. My ball is gone, but I can't do anything. So this approach, considering only the ball, means ball is flowing and I am seeing that ball flowing. This approach is Eulerian approach, where I will see. So ये particular location पे हम इस ball को देखते जा रहे हैं. So this approach is Eulerian approach. Now I will consider this. I will tie this ball with a thread. अब मैंने क्या किया, मैंने इस बॉल को एक थ्रेड से बांध दिया यहाँ पे और पकड़ के रखा हो. And this water is flowing in the river, and I am seeing this ball is steady in this river position, and I am seeing, मजा देख रहा हूँ मैं बॉल की, पानी फ्लो हो रहा है इसके आसपास से. And now I am considering this part only, this part only of the river. इतने ही पार्ट में मैं बस देख रहा हूँ कि बॉल कैसा ऊपर नीचे पानी पर हो रहा है. So I am considering this part of the river, not considering whole river, not considering that ball how it is flowing. So बोलने का मतलब यही है कि जब मैं किसी एक पार्टिकल को पकड़कर फ्लो में जाता हूं, मैंने एक पार्टिकल लिया किसी फ्लो में, किसी पानी में एक कोई एक इंक डाल दी, वो इंक कैसी फ्लो हो रही है ये देख रहा हूं. तो दिस अप्रोच इज मीन्स सिंगल पॉइंट अप्रोच, मीन्स किसी एक चीज को लेकर हम किसी चीज को अगर अंडरस्टैंड कर रहे तो दैट इज Eulerian, मीन्स एक सिंगल पॉइंट अप्रोच. और अगर अदरवाइज मैं किसी एक सिस्टम को कंसिडर कर लेता और उस सिस्टम में जितने भी पार्टिकल आने वाले फ्लो के उसको कंसिडर करता हूं, तो ये होलसम अप्रोच, एक इंटीग्रल अप्रोच हुई है, इसको बोलते हैं लैग्रेंजियन अप्रोच. तो हमने सबसे पहले क्या किया, एक एप्लीकेशन लिया, एक कार लिया हमने, उसको हम डिजाइन करने वाले हैं. उसके बाद उसमें फ्लूइड इन्वॉल्व देखा, क्या है, एयर है. एयर के बाद क्या है, एक्सटर्नल फ्लो है, इंटरनल फ्लो है, एक्सटर्नल फ्लो है. फ्लो विजुअलाइज किया, कैसे फ्लो होने वाला है, ये ऐसे फ्लो होने वाला है, ऊपर से नीचे से बीच में जाएगा, खिड़की में जाएगा, ये हमने विजुअलाइज किया. उसके बाद हम क्या कंसिडर करने वाले, Eulerian या लैग्रेंजियन. तो हम क्या कंसिडर करने वाले, एक कार के ऊपर कितना फ्लो होने वाला है, इतना ही देखने वाले हम. एक एयर का पार्टिकल तो नहीं देखेंगे ना, कौन इतना एयर का अंडरस्टैंड करेगा. तो हम क्या करेंगे, कार के ऊपर कितनी एयर फ्लो है वो देखेंगे. तो हम एक अप्रोच से जाएंगे. तो हमने अभी तक 5 टॉपिक हमने फ्लूइड मैकेनिक्स के कंप्लीट कर लिए. कैसा लगा, अच्छा लगा भैया? सिलेबस खत्म हो रहा है? हेलो.
हाँ सर.
So what I'm telling is कि this all things we are going to learn in detail, and the questions will be asked on this topics only. मैं बस एक ओवरव्यू बता रहा हूँ, इसको हम डिटेल में पढ़ेंगे. तो बेसिक आइडिया यही है कि हम किसी एक एप्लीकेशन के लिए क्या क्या करना पड़ता है, इसी चीज को हम फ्लूइड मैकेनिक्स में पढ़ने वाले हैं. तो यहां तक हुआ ये एक एप्लीकेशन का. तो आगे आता है, जैसे मैंने कितने लोग, हर किसी को पता है कि पानी उठाने के लिए पंप की जरूरत पड़ती है ना. तो क्यों पानी लिफ्ट हो जाता है पंप से, किसी को क्या लगता है, क्या कोई बता सकेगा कि पंप क्यों पानी उठा लेता है? चलो वो जाने दो. किसने बर्नौलीज इक्वेशन का नाम,
प्रेशर डेवलप होता है.
ओके, वेरी गुड
सर. और मतलब डेंसिटी डिफरेंस की वजह से भी पानी ऊपर चढ़ सकता है.
ओके,
बिना
yeah, that is also a very beautiful point. So सबसे इम्पोर्टेंट पार्ट कि किसी भी मास में अगर मतलब कोई भी चीज है तो उसका मास है, तो उसमें एनर्जी रहती है, तो उस मास के साथ हम खेल सकते हैं. So Bernoulli equation, heart of fluid mechanics, बर्नौली इक्वेशन का इस्तेमाल करके फ्लूइड मैकेनिक्स के 50% प्रॉब्लम सॉल्व किए जाते हैं. सो दैट थिंग दैट अलोन कंसिस्ट ऑफ एन ह्यूज पार्ट ऑफ एप्लीकेशन इन फ्लूइड मैकेनिक्स. सो दैट इज एन वेरी इंपॉर्टेंट formula, one formula, single formula and huge application. So what is Bernoulli equation? That is basic idea behind that is an anyone? कोई बता सकता है?
एनर्जी एंड मास कंजर्वेशन होता है उसमें.
Okay, very good. So that is an energy balance equation. बर्नौली इक्वेशन में क्या क्या टर्म्स होगी? किसी भी चीज में कौन सी एनर्जी रहती है? कोई अगर मोशन हो रहा है तो मोशन में कौन सी एनर्जी इन्वॉल्व होती है?
सर पोटेंशियल, काइनेटिक.
पोटेंशियल एनर्जी, काइनेटिक एनर्जी और
प्रेशर एनर्जी सर.
या वेरी गुड. किसी फ्लो में अगर कोई चीज फ्लो हो रही है तो उसमें एक काइनेटिक एनर्जी होगी, एक मोशन होगा तो काइनेटिक एनर्जी. वो किसी अगर हाइट पे है या किसी उसकी डेटम से क्या हाइट है उस पर उसकी पोटेंशियल एनर्जी डिपेंड करेगी. एंड इफ यू आर अप्लाइंग एन एक्सटर्नल, और अगर उस फ्लूइड का मास है तो उसका एक प्रेशर बनेगा, या एक्सटर्नल एजेंसी से अगर कुछ लगा रहे हैं तो उसका एक प्रेशर बनेगा. सो दिस इज कॉल्ड फ्लो एनर्जी. कुछ लोगों ने ये टर्म सुनी होगी, फ्लो एनर्जी. सो उसमें होगी फ्लो एनर्जी. तो ये 3 टर्म्स मिला के बनता है बर्नौली इक्वेशन. किसी को एक्सप्रेशन पता है क्या बर्नौली इक्वेशन का? v²/2g काइनेटिक एनर्जी को दिखाने के लिए, डेटम को दिखाने के लिए z, और mg वी कैन से दैट पोटेंशियल एनर्जी, और प्रेशर के लिए P/. ओके, सो दिस रिमेन्स कांस्टेंट. व्हाट बर्नौली सेज इज किसी 2 पॉइंट पे किसी फ्लूइड की एनर्जी कांस्टेंट रहेगी. ये इक्वेट करते हैं किसी से हम. तो ये जो बर्नौली इक्वेशन वाला पार्ट है ये आपका 10% ऑफ फ्लूइड मैकेनिक्स के एप्लीकेशन में आएगा, और इसमें से 10% प्रॉब्लम आपके आएंगे ही आएंगे. मैनोमीटर बहुत लोगों ने सुना होगा, मैनोमीटर, फ्लो मेजरमेंट डिवाइसेस एंड मेनी डिफरेंट थिंग्स. Everywhere there will be application of Bernoulli expression. So that thing we are going to learn. So this 6th topic is completed. That means we'll complete it. So till now we have completed the 50% syllabus, 15, we can say 60% syllabus of fluid mechanics. Overview, I am saying overview. I haven't completed the syllabus. So this अभी तक किसी को लगा कि मतलब काफी हार्ड है, मगर प्रॉब्लम सॉल्व करने के पहले पीछे की बेसिक आइडिया पता चल गई तो हम प्रॉब्लम को कनेक्ट कर पाएंगे. सॉल्व करते समय हमें पीछे का कंसेप्ट मालूम रहेगा कि इसका एप्लीकेशन क्या है, व्हाई वी आर गोइंग टू सॉल्व दिस प्रॉब्लम. सो दिस अप्रोच आई एश्योर यू कि ये आपको बहुत काम आएगी जब आपको पीछे का कंसेप्ट पता रहेगा कि हम क्यों कर रहे हैं, हम पढ़ तो रहे पर क्यों पढ़ रहे, क्यों सॉल्व कर रहे इस प्रॉब्लम. ये जब आपको पता रहेगा you will put different approaches to solve that problem. That is the beauty of understanding the application way से पढ़ने का वही एक फायदा होता है कि हम जब प्रॉब्लम सॉल्व करने जाते हैं तब हम रुकते नहीं है, हम कुछ ना कुछ लगाते हैं उसमें. सो दैट्स व्हाई आई एम सेइंग कि अगर हमें ओवरव्यू पता होगा सब्जेक्ट का कि हम क्या कर रहे हैं इस सब्जेक्ट में, तो दैट थिंग विल डेफिनेटली हेल्प यू. और हम इस चीज को इतना डिटेल में देखेंगे कि आप रियल लाइफ एग्जाम्पल से ही आप समझ जाएंगे कि ये प्रॉब्लम सॉल्व कैसे होगा. So that thing that the team of fluid mechanics we are having is definitely going to teach a way that you will never forget the applications and you will never forget how to solve the problem. So आगे बढ़े. तो आगे आता है, हमने अभी तक एप्लीकेशन देख लिया बर्नौली का, कैसे फ्लो को विजुअलाइज करना है, किस मेथड से कर सकते हैं. या तो एक पार्टिकल को कंसिडर करके कर सकते हैं, या तो एक वॉल्यूम लेंगे उसमें के किस बहुत सारे पार्टिकल्स को कंसिडर करके कर सकते हैं, या उस वॉल्यूम को एनालाइज करके कर सकते. तो ये आइलरियन, लैग्रेंजियन. सो सेम थिंग अगर मैं एक पार्टिकल मैंने क्या किया, एक रूम लिया, उस रूम में अगरबत्ती जला दिया. भगवान की पूजा भी करना बहुत जरूरी है. अगरबत्ती जला दिया, अगरबत्ती की फ्यूम्स पूरे रूम में चली गई, पर किसी एक कॉर्नर में दिस सेंट इज मोर. तो मैं इस कॉर्नर में एनालिसिस कर रहा हूँ कि यहाँ पे कितने पार्टिकल है, यहाँ पे फ्यूम का वॉल्यूम क्या है, यहाँ पे इस फ्यूम का प्रेशर कितना है, यहाँ पे इस फ्यूम में मतलब इसने कितनी स्पेस ली है। तो इस चीज का अगर मैं किसी पॉइंट पे अगर मैं एनालिसिस करता हूँ या स्टडी करता हूँ, तो दैट थिंग इज कॉल्ड डिफरेंशियल अप्रोच ऑफ लर्निंग, मीन्स अंडरस्टैंडिंग द फ्लो बिहेवियर। सो दैट डिफरेंशियल अप्रोच। मगर अगर मैं पूरे रूम को कंसिडर करता हूँ कि पूरे रूम में कितना प्रेशर है, कितने फ्यूम्स है, कितना कितना स्मेल आ रहा है, तो इस चीज को बोलते हैं इंटीग्रल। इंटीग्रल का मतलब ही क्या होता है, ओवरऑल, है ना, पूरा कलेक्टिव। सो दिस टू 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 काइंड्स ऑफ अप्रोच वी फॉलो इन फ्लूइड मैकेनिक्स टू अंडरस्टैंड द फ्लो बिहेवियर एंड फ्लो। तो ये काफी गंदा हो चुका है, मैं आपको एकदम आसान से बताता हूँ कि ये इंटीग्रल और डिफरेंशियल अप्रोच कहाँ कहाँ यूज होगी। हाउ मेनी ऑफ यू प्ले क्रिकेट? कोई प्लेयर है क्या? सबने ही खेला है, चलो। तो प्लास्टिक के बॉल से खेलते समय किसने किसने देखा है कि वो ऐसा वेव होते हुए जाता है, कई बार ऐसा हवा चल रही है तो ऐसा, या तो शटल कॉक ले लिया अपन ने, अपन बैडमिंटन खेल रहे तो बैडमिंटन खेलते समय ऐसा मारा मैंने, और सामने वाले, मैं तो जोर के मार रहा हूँ पर सामने वाले के पास पहुंच ही नहीं रहा, वो बोलता है यार ताकत ही नहीं है ना? देखा है क्या सब लोगों ने? क्यों होता होगा वो, क्यों होता होगा? एयर टकरा रही है, एयर रेजिस्ट कर रही है ना? तो एयर किस तरह से रेजिस्ट कर रही है, उसके दो अप्रोच हम कर सकते हैं। या तो एक पूरा ओवरऑल एयर को कंसिडर करके उसमें थोड़ा सा पूरा बिहेवियर जान के, या तो फिर किसी एक पॉइंट पे एयर को लेंगे और उस पर क्या उसका फ्लो है, क्या प्रेशर है, वो कंसिडर। तो ये दो अप्रोच हम यूज करेंगे, इंटीग्रल और डिफरेंशियल अप्रोच। इंटीग्रल को ही रेनॉल्ड्स ट्रांसपोर्ट थ्योरम बोल के हम पढ़ाई करते हैं इसकी। तो ये एक चीज हो गया, है ना। फिर आता है डायमेंशनल मॉडलिंग, फ्लूइड मैकेनिक्स का एक छोटा सा टॉपिक, बस मोस्ट इंपॉर्टेंट। क्वेश्चन तो दिखना ही दिखना है डायमेंशनलेस नंबर से, डायमेंशनल मॉडलिंग से। क्या होता है, आपको एकदम आसान भाषा में ये टॉपिक तो हम आज ही खत्म कर देते हैं 2 मिनट में। डायमेंशनल मॉडलिंग का बेसिक आइडिया, बहुत बहुत बार इसके पीछे बहुत दिमाग खराब होता है हमारा, पर समझ में नहीं आता है डायमेंशनल मॉडलिंग क्या है। तो व्हाट इज डायमेंशनल मॉडलिंग? व्हाइल मेकिंग एन बिग machine or prototype or anything they try to make, means scale up. So first they make a small prototype of that, a small instrument or small prototype, a small car they make. Then they understand the flow behavior around that, how the flow is flowing over that car, how the design, how sleek they can make, how they can cut out the extra mass of the car. So first they understand on small scale, because in making this car, if I will take an 1 lakh rupees metal body or 2 lakh rupees metal body, that all is going to go in scrap. And this is in car. If I'm doing for chemical testing, that in chemical testing they make in small beaker, chemist make in small beaker, and chemical engineer make it on reactor. So if I will first go on reactor, then chemical cost crores of rupees, lakhs of rupees, that all things will be dumped, and that money will go to waste. So that's why what they do is first they do it in small scale, and then in ratio, if I do 10 kg of chemical, 10 kg of NaCl I mixed with 5 kg of means NaOH. So I'm going to make a different chemical. I'm going to make a different chemical. So what I saw is, for making some chemical, I need 5 kg of NaOH and 10 kg of NaCl in small scale. So I will find some parameter, one ratio I will find, where I will see if I take 10 kg of NaCl and 5 kg of NaOH, then I get 12 kg of that chemical, some chemical. So if I want to produce 12,000 kg of that chemical, then what will be that converting parameter, so that I will decide how much kg of NaOH and how much kg of NaCl I will take. How many of you understood what I want to say? 10 kg I took NaOH, 1 kg I took HCl. I will make 2 kg of NaCl. Now I know reaction that 1 kg of HCl will give when reacted with some kg of NaOH. Not I'm saying 10 kg. I'm saying some kg. So it will give 2 kg of NaCl. But I want to know if I want to make 200 kg NaCl, then I know I will require 100 kg HCl. But I want to know kitna kg NaOH lagega. So there will be some converting parameter ratio. Let's say this is a ratio of conversion. So that ratio is governed by a number called dimensionless number. How many of you know the term dimensionless number? और एक अच्छे एग्जांपल से समझा तो 2x plus 5 gives 20. Okay, so what will be the value of x? We will not say 20. What will be the value of x? Okay, leave this example also. So basic idea what I want to say is, if you have to convert a small prototype into big one, we will give a multiplication factor. Let's say in easy language, it is a multiplication factor to grow it in the large scale. Dimensionless number is, dimensional modeling is conversion factor, that multiplication factor. If I want to get 100, then I will multiply 2 with 50. Means I am growing 2, the small number 50 times so that it becomes 100. अब समझा किसी को? Okay, we'll see in detail. I'm just giving an overview. We will consider by example. We will give a proper example for this dimensional modeling and dimensionless analysis. So what I wanted to say is, so far we have learned how we will apply fluid mechanics by learning the flow behavior and at any particular point, or considering some room, considering any volume, we will understand the flow behavior and then we will apply to the models and applications. So these are applications of fluid mechanics, major applications. External flow में car वगैरह आ जाता है, and this things which goes in fluid like a ball and the shuttlecock. So if the car is moving in this direction, the air will put a pressure on this front glass, this body. It will go above, it will enter in your window. So this all things will be governed by fluid mechanics, and we will learn the fluid mechanics by this example only. एक example में आपका पूरा fluid mechanics आपका complete हो सकता है, if we wish. So इस एग्जाम्पल को कंसिडर करते हुए हम आगे के टॉपिक्स पढ़ते जाएंगे. वी विल लर्न द नेक्स्ट टॉपिक्स कंसिडरिंग द एग्जाम्पल. सो दिस आर द एग्जाम्पल ऑफ एक्सटर्नल फ्लो एंड दिस वन इज इंटरनल फ्लो. द इंटरनल फ्लो टॉपिक इज वेरी इंटरेस्टिंग. यू विल many of you will enjoying the watering the garden. बहुत लोगों को पाइप के मुंह पर दबाकर उसको प्रेशर मींस that closing half of the pipe and increasing the pressure of that flow. How many of you enjoy? Yeah, so many people enjoy that. I personally enjoy it. So मुझे बताने का अच्छा लगा. So that thing means पाइप के अंदर कैसा फ्लो होता है, that thing we are going to see in detail in internal flows. So इंटरनल फ्लो में इस पोजीशन पे क्या प्रेशर होगा, इस पोजीशन पे what will be the velocity, what will be the stress, what will be the viscosity of the fluid, how the flow will go inside the pipe. That all the things we are going to learn in fluid mechanics, and all the topics of fluid mechanics considering this example you will understand, and the syllabus will get completed. We'll solve problems. Example एक बार समझ गया, if we learn the example, then you will easily solve the problems. So that's all from my side. This is an overview. Not we haven't learned this in detail yet. Everything I discussed, we will go in detail for that. This is an basic overview, chapter 0, which means कि मैं एक बार में आपको पूरा subject बता दूं कि what is fluid mechanics. So I hope it was an helpful for someone, many of you. Okay, then we'll meet again in fluid mechanics.